Alright, so in this video, we will create the month value column. To do this, we must find a way to deduct the month value contained in each date we have in DF. We will now show you how this can be done with pandas. Let's examine the first value of the date column. It is a timestamp, 7th of July, 2015. Moreover, the time is set to midnight. We don't see a different time because a timestamp value created with the pandas to datetime method always contains two parts, a date and a time. If we didn't have time recorded in our dataset, Python would have assigned zeros to the time component automatically. So, please don't be surprised when you see these numbers next to the date. Now, to extract the month value only, we need to type .month at the end of the same expression. Run this cell and here you go. We got 7, representing the 7th month of the year, July. Awesome! Please remember that the months take values from 1 to 12, not from 0 to 11. How come this is the case? Simply because the person who wrote that library, Pandas, decided this is more intuitive. Therefore, that's how it is. So, we better just get used to the convention. The programmatic pattern we'll use for creating the month value column is the following. We would like to create a list that we will fill with the month values of the dates, and then we will assign the values of this list to a new column in DF, naming it month value. Okay? Sure, let's begin. First, to an object we'll call list_months, we will assign an empty list. Press Shift and Enter to execute this operation. You can see the output is an empty list. Great! Second, we will use a loop that will iteratively extract the month value of every date we have in the date column. To do this, we'll employ a for loop. So, let's build up this code block from the bottom up. The dfDate.month operation must be appended to the list_months list. Intuitively, there's the Python append method, which attaches the new value obtained from each iteration to the existing content of the designated list. Put more simply, during the first iteration, the loop will obtain the number 7, and this will be the first value in list_months. Then, with the second iteration, the loop will deliver 7 again, and this will be the next number in our list, and so on. Okay, we hope this is all clear. However, how many iterations do we need to complete list_months? Surely, no more and no less than the lengths of our data frame, which contains 700 rows, right? So, thanks to the built-in range function, we can say for I and 700, meaning for I, taking each of the values from 1 to 700, execute the subsequent operation. This will tell Python to extract the month value from each of the 700 dates, retrieving them one by one, and storing them in list_months. Despite the fact that this will work perfectly in our case, there's a more professional way to designate the number of iterations. What if you substitute your data frame with another one which is of a different length? In that case, 700 values in list_months won't match the length of DF, and the creation of the month value column will not be successful. So, to iterate as many times as the number of rows we have in our data frame, we need to refer to the shape property of DF. It'd deliver two values. The first represents the length of the data table, and the second one stands for its width. As a consequence, to indicate that we'll need the first of these values in our loop, we need to write range open parentheses df.shape 0 in brackets, close parentheses, colon, at the end of line 1. Wonderful! Let's press Shift and Enter to execute the code written in this cell, and then check the content of the list months. Okay, we see that our data has been ordered by years and months then, starting from July, going through December, and then starting from January all over again. By implementing the built-in len function, we can prove that the list contains as many as 700 elements, which coincides with the number of records in our data frame. This means that up until now, we have worked correctly. What is left to do is create a new column in our table by typing df and month value in brackets, and then assign the numbers from our newly created list by writing equals list underscore months. Execute this cell to apply this operation, and run the next one to check the top 20 rows of df. We see that the month values have appeared in the far right corner of the screen. Lovely! We are ready with this part of our exercise too. From the perspective of our analysis, what we just did will allow us to check whether in specific months of the year, employees tend to be absent more often compared to other months. Following the same logic, it may turn out that on certain days of the week, workers may be more prone to be away from the desk than on other days. I mean, you'd probably think one would rather leave earlier on Friday than on Monday. But is it so? The subtask of our next lecture will be to create a column designating the day of the week. See you there.